Welcome back, and here we are. We're in the last video. This is 8-5 in module 8. Now, I labeled this one, What's in a Name? And can I call myself on the phone? Um, we'll start out with what's in a name. I keep saying that these things that we're dealing with are objects. There's a class of code that we make a copy of it or clone it and call it what we want. Just like there could be a class of individuals that when we make an instance of them, it's a student class. Let's make an instance of a student class. And I'll create some student objects. Oh, wait, we already did that. You're all instances of the student class. Each one of you is a student object. And students have certain functionality and attributes associated with them. They're inherited from that parent class. And I dig more, and I think it's the next module, relative to object-oriented and classes and such. And it is the next module. I had to check and make sure. So, these objects and classes, they have specific names, and they have, like I said, functionality associated with them. And then some of that functionality is standardized. And there are things that we do, like I mentioned in the previous video, there's things that are global and things that are local. And I want to talk about this concept of global and local, and here's a good example of it. Now, if something is outside and it's in our code, this word animal, the variable animal, it's a string, has been declared and assigned a value of fruit bat. It's not in the function, so it's not local inside the function, it's outside, and we'll call that a global. Now this is implicitly global. Now what I can do to be explicit, just to make sure, I can define the global variables. Global animal. And I'm explicitly saying, hey, animal, that's global. You're going to be able to access it everywhere. Oh, okay. Now, there's drawbacks to being able to access things everywhere. And I alluded to that when I talked about making a copy so you don't mess up the original. If something's global, anybody can get their hands on it. When we deal with object-oriented in the next module, we'll dig deeper into this concept of global and local, and we want to protect things to where they don't get, I don't want anything happening to the original because I need to reuse it. So in this example, I'll go ahead and get rid of this because it's implicitly taking place here. We define a function called print global. It doesn't require any arguments from us. It's empty. And it says print, passes it a string literal variable, comma, and it passes the print function animal. But we didn't give this function animal, but we have the expectation that print knows what animal is. Print global didn't give it to him. If I print here, string literal constant at top level, comma, and pass animal, that's a global. And I'm performing this task globally. It's not inside of a function. It returns at the top level fruit bat. When I call the print global function, I don't pass it anything. We're inside there. Animal, it's inside. Does that mean it's local? No, not necessarily. If I declared it inside, it means it's local. But because it was declared globally, it's accessible inside. This is important. And the reason it's important is you got to be real careful in where these variables exist and what names you give things. You can call something all too often people make a mistake and they think, well, I can reuse that name over here. And then the system has a problem. Are we local? Are we global? Did you overwrite the other one? What's taking place here? So we got to be cautious in how we use our names, because when we created the instance of the class, that's a special name. And we don't want to give another object that same name. I'm going to have, student 1, student 2, student 3, but not multiple objects called student. It just doesn't work that way. Okay. In this example, animal is referenced before it's created. There it is. It's referenced before it's assigned. Because, wait a minute, we did it back here. Animal's fruit bat. That's global. Come over here. Wait a minute. This is where I was talking about. You got to be careful naming something the same as it's named elsewhere. Because this one's the global animal. This one's the local animal. Since there's a local animal here, it knows there's a local animal, and it's like, wait a minute, you can't reference this local animal before we've assigned a value to it. No, I meant the outside one. Yeah? So this is where it gets ugly. We got to be careful about the names and not reuse names, and be cognizant of the data type and what values exist at what point in time. We need to protect these things to make sure they don't get changed. On this one, we're just changing values. Animal had a value of wombat. Inside local, wombat ID animal. ID. Let's run it, see what happens. Inside local, the value, that's where that value is stored. Animal, or the pointer to get to it. Now, we print animal, print ID animal, and we've got a different one. We've got a different one. Okay. With this one, we declare a global. We declared a local with the same name. We're playing with fire. And we'll end up with confusion as a result. Now, since we said global animal here, we overrode it and said, hey, this isn't a local animal. This is the same as over there. So anything we do here is going to impact that one. It's not a local one. Had we done this the other way, hang on. format that. Fruit bat. But inside, it's local. Take that off and run it. Now, whatever we do inside impacts outside. So we've got that to contend with. It's an issue. And we're creating, we've got a function that we're calling, which is locals. And if we call it in that function, it'll tell us what functions exist locally. If we call the other one, it'll tell us what functions exist globally. So, what functions exist locally? Animal and wombat. Wait a minute. They're not functions, they're variables and potentially functions. So there's no sub-functions in here or inner functions. We've just got, and it's telling us the local objects. What local objects do we have? There's animal, right there. And in a dictionary format, that key has the value of wombat. Okay. What do we have beyond that? Well, globally, what objects do we have? Oh, there's a name object. That's the name of the object itself. There's a main. There's doc for that documentation we talked about before. There's a ton of stuff in here. All kinds of stuff that's available, built into these objects that exist in here, or the overall class that we've got. Now, you'll see here, double quote, or double underscore, double underscore. Python uses two underscores on the front and back of names, and that's a Python thing. You may not see that in other languages. And essentially what that means is that's the name of some function that is built in. So there's a function called amazing, or no, there's a function called amazing. And let's print the function's name. Well, the name is amazing. Let's print the function's documentation. Anything in those triple apostrophes. Boom. It's that doc string. So that's a built-in function. The name function will return the name of the function. The doc function will return any string docs that's in there. So there's a bunch of built-in functions, and you know they're built in because they've got the two underscores there. Now, at the beginning of this, I said something about, hey, can I call myself on the phone? And there's a concept that I'm not really going to dig into in this class, other than explain what it is. So if somebody uses this word, you'll, oh, I know what he's talking about. So we've got functions that exist. We've created them. And we just have gone over all kinds of different things that we can do to create our own functions. We've got functions we've used time and time again. And what if we had a function like this? Define dive. It doesn't require anything from me. And dive will return dive. So what do you see here? That's calling the dive function. You define the function that calls itself. So if I called it here, That's like saying, hey, dive, run. Okay, call dive. Okay, call dive. Okay, call dive. And you're just in this infinite loop. There's no mechanism in this to get out of it. Why would anybody want to do that? Well, there are aspects of programming that, when it comes to solving the problems, this concept of recursion helps you to resolve things. And it could be, let's say I had nested loops. Loops inside of loops inside of loops. And I want to have this nested functionality so that if this is the case, as long as this condition is true, I'll do this again, but on the inside of that other call. The only thing is, I need some way to stop it. I need some way to break out. This recursion can be a real great tool. But if you don't know what you're doing, you end up with, it could potentially be a infinite loop, unless this says right here, recursion error, maximum recursion depth exceeded. So essentially what happened was, we tried to do something and it said, wait a minute, I'm not sitting here spinning around in circles doing nothing. And at a certain point it says, all right, I'm done. I'm not doing this anymore. And it threw the error, and the error is, look, it's essentially the computer yelling, saying, this doesn't work for me. This is going to lead us to where we're going next. How to deal with the computer saying, I don't like what you did, or you did something wrong, or hey, that didn't work. If this thing did not throw an error, and that's what we call it, throwing an exception or throwing an error. We tried to do something and it threw a wrench in the works and stopped everything. Literally stopped it, as you see here. And if I wanted to find out more about it, I can click on this and go to Stack Overflow. Great resource. But what I can do is I can address these errors programmatically to where it doesn't shut everything down if it didn't work right. What I can do, and I said, hey, we can go through this. We can do this as long as we have control over it. Here's recursion, where we're dealing with flatten. We're calling within one, calling it again, and that's fine until we need to get out. We need to get out. In this instance, it lets us get out. It does let us get out. And essentially what this does is it takes a multi-dimensional array, or in this case, a multi-dimensional list. And this is really ugly. It's like lists inside of lists inside of lists. And instead of having all these lists inside and next to each other, say, look, let's just flatten this thing. And there's another way to go about this, a cleaner way, but it's beyond the scope of what we're doing here. We want to flatten this thing out and just put it all in one nice little neat and clean list. One dimension instead of maybe three. So that's what we have taking place here. This is recursion, and instead of dealing with recursion and letting it get out of hand, we can use it. Let's jump over to the exceptions. And we don't have much left. And I'm not going to dig super deep into exceptions. If you take any of the next level classes beyond this one, you will deal with exceptions. And exceptions are, as I said, the system saying, hey, this doesn't work. We've got a problem. Either you're trying to multiply words, can't do that. You're trying to divide by 0, you can't do that. And here's one, you're trying to get to a position outside the list, the range of the list. So this list has 0, 1, 2. The maximum index on this list is 2. And we're saying, hey, let's get to position 5. Short list index 5. There is no short list index 5. So it essentially says, hey, here's the error that is being thrown, or the exception that's being thrown. And sometimes you don't understand what they are, and you need to go to Stack Overflow. And I got beat up with some. I've been working on a project for the last 6 days that I would get hit with exceptions, and I'm like, wait a minute, what did you expect? Oh, okay. Now let me try and figure out where it is exactly. And much like if we were still using MindTap, like I may still be doing in some of the other classes, C# or C++ or data structures. In those classes, if I'm using MindTap, we don't have this kind of resource to fall back on. We got to go figure it out. And it can be cumbersome. And even if you know what the error is, trying to find out what caused it. Well, it's telling me short list position, that index is out of range. Well, that's easy. But some of the other exceptions that you may run into, they're going to beat you up. So how we deal with this is we use the try, except. In other languages, we call it try, catch. Okay? And essentially we're saying, hey, let's try this and see if it works. And if it doesn't, then do this. And what essentially this line of code says is try this. Short list index 5, and if it doesn't work, print out a message and let them know, hey, that didn't work. So you saw what happened before when we were out of range and didn't handle, it's called exception handling. We didn't handle the exception. Well, here, we handled it. Try, except, or try, catch. Try, we tried this. It threw an exception. Let's catch it and deal with it. In this language, we say we got the exception, accept, and deal with it. And our code kept going. We can keep going in our code without shutting the whole thing down. Maybe one little aspect of it didn't work the way we wanted it to. That doesn't mean the whole program shuts down. Sometimes you may want to have it throw an exception. Sometimes you may want to catch the exception and display what it was. I want to catch the exception and I want to display what the exception was, but keep on going. And that's something that we would want to do. Okay. Here's a way that we said we try it here. And position equals int value, and we know that's beyond. Or it could be a different exception. So we're going to try it. If the exception is index error. So try it. If the exception index error, and we're going to save it as error, print bad index and the number. Or run this. Oh, 9. No, that's not going to work. 2, 3, Q. Now, what if, comma, if I go this way? 9. 9 list index out of range. Now wait a minute. 9 list index out of range. Error, ERR, is what the error is. So a lot of times my print statement will be, you threw an exception and I caught it, and here's what it was, and here's why it got created, because you passed a 9 and the maximum was this. So we can do things like that to let the developer, the person that's testing the system, know what the error was. And we've got that Q to get out. Okay, so if we wanted to, we could create our own exception, build it out, and if something happened, it would raise, if word is upper, it does a test. If that test is true, raise uppercase exception and pass it that word. So we've got uppercase exception. What is the exception? And then pass. So when we run this thing, we raised the exception, we passed it word, whatever the word in words was, and it's MO, and then we get that exception got thrown, and the name of the exception is uppercase exception, and it also passed us out word. So there's things we can do to, let's say the user did something and we didn't like it. I don't want you entering data like this. I can do a try catch, and if they do something that's not the way that I want it, I'll throw them a little message up. And we can do that much like we had back there. Okay. So we can declare our own exception. We use pass. There's nothing actually taking place in here, but it exists. It's been declared. And try to raise the exception and pass it panic. Except, here's how we catch it. So we're raising the exception. We're passing that exception panic. We take that exception, we call it exec, print exec. Remember what I did before with ERR? Yeah, that's the same concept. And it just tells us here's what the exception was. And it can be whatever message we want. Right. Here's a great link that I've got down in the bottom if you want to go play with this more. And do it in other languages as well. See how it's done. It's helpful in the sense that if you're in a loop and you have your code doing its thing, it's going round and round and round and round, you may want to, if the loop gets to this point, throw an exception. And the exception is loop out of bounds, or something like we saw, index out of bounds. You can create your own. Loop out of bounds. Loop exceeded 50. All right, I don't want it going beyond 50. There's things like that to help you debug your code along the way. So I've got some stuff down here for you to play with. Add cells into this. Once you've created your own copy of this notebook, add cells in, play with these things. Now, inevitably, people say, well, I don't have time for that, I don't want to deal with it. The more you explore these things, the more you play with them, the more you try them. Modify them and run them, modify them and run them. Go back, Control Z, undo what you did, make it to where it can still work. At least you played with it, you explored. When the time comes and you get the next graded notebook, you'll have that experience of dealing with it, playing with it. Go play with the things I've got down here below. Create your own instance of these things, and I'll add more in there. Okay. I will see you in Module 9.